SQLite in threads. How can I access the same SQLite database from multiple threads? Welcome to my second session. This time it's all about using an SQLite database from threads. For those who don't know me, my name is Frank Lauter. I'm an Embarcadero MVP and I have been programming in Pascal and Delphi for over 35 years. For more information, please visit my homepage, where you also can find information about my services like source code review and consulting. My favorite topic is the development of FireMonkey application, for which I also offer training in your office or remote. As well as my blog From Old School to New Frontier on Blogspot, and the German version of my blog, which can be found on the Embarcadero homepage. It deals mainly with my favorite topics, MVVM, FireMonkey, and my FireMonkey development kit, which offers many useful features also for VCL developer. In order to spread these topics even better, I've started this year by publishing video series on my YouTube channel, Delphi Profi. Of course, I'm happy about everyone who subscribes to my channel and links to it.
What do threads have to do with SQLite? Actually, nothing, or a lot, depending on how you look at the topic. But let's start at the beginning. The difference between a file-based database and a database that has a real server is simply in the possible endpoints. A database server can certainly receive many hundreds of connections, but the routine responsible for the integrity of the data on disk can read all incoming requests from a queue and process them one by one without causing a problem with the actual data file on disk. A file-based database cannot prevent the data file from being accessed simultaneously from multiple endpoints, unless the driver already does so. Locking and other corresponding mechanisms are simply ignored here. But we have to distinguish whether we try to access the database with several programs or with several threads from the same application. Of course, the file system offers the possibility to restrict the read or write access. But do we want that? So, a lock would not only lock one table, but all tables at the same time. This consideration is actually applicable to all databases, unless they offer a better mechanism. So let's have a look at the SQLite documentation first. SQLite offers three different threading models. The first is single thread. In this mode, only one thread can access the database at a time. 2. Multi-threads. In this mode, you can access the database with several threads, provided that a connection is only used by one thread. 3. Serialized. In this mode, the database can be used by multiple threads without restriction. There are three ways to use the corresponding mode. 1. You can compile the database with the appropriate setting. Okay, I didn't want to do this myself, but you can. 2. If the database was not compiled in single-thread mode, you can specify the mode during initialization. 3. If the database was not compiled in single-thread mode and you did not specify single-thread mode during initialization, you can choose between multi-threaded and serialized mode for each database connection at runtime.
Whew.
So far the SQLite documentation. Can you still follow me? But what does this mean for us Delphi developers? So let's have a look at the doc wiki. Here we find exclusive update of DBs, set journal mode to WAL if necessary, few simultaneous update processes, set locking mode to normal, and it enables shared DB access. Set synchronize to normal or full to make transferred data visible to others. Whatever that means. Set update options.lockWait to true to enable waiting for locks. Increase busy timeout to extend the waiting time for locks. Set journal mode to wall. Then set shared cache to false and isolation to snapshot or serializable to prevent deadlocks. Okay. Sorry, but if you are 100% satisfied with this, please do a tutorial on this topic. On Windows I could adjust the SQLite.dll and if necessary put a different compiled one. But how is the database initialized by FireDAC at startup? Well, you could certainly find that out too. How are the SQLite drivers pre-installed on iOS or Android compiled? Can we assume that the manufacturers follow the default mode and that the drivers were compiled with serialized and that FireDAC does not start in single-thread mode? Questions about questions. If you Googled, you'll find hundreds of posts that all say that multiple threads are not allowed to write at the same time. Very strange. The SQLite FAQ says, in other words, locking of files in the network is buggy and you can't rely on it and unexpected problems can occur. Threads would be diabolical anyway, and the thread locking system would only get into the database because developers ignore the warnings. Let's take a look at how the locking system works. When a transaction is started, the database is locked. Okay. The database is not released when the commit happens, but only when all data has been written to disk. Sounds good, right? So if a thread writes something and another thread wants to write it too, it has to wait. Also okay. The problem is, if the first thread opens a new transaction after the commit, before the database is released, the thread with the same connection can do that, and the database remains locked for the second thread. So, I just don't feel like relying on how the database drivers were compiled or how FireDAC did it. What if I want to switch to another database? Or use UniDAC instead of FireDAC? Also, I don't want to test all the different settings to find out that the update to the next version will be different. Apart from that, if everything would be so easy, what would my session be for? So I assume that no matter what database, driver or component I use, nothing of it is thread safe. And as I assume from this worst case scenario, everything will actually be much simpler. I take a thread so that my database can always be accessed in the background. If I want to access the same database from multiple threads, I serialize all calls asynchronously through this thread. This works with any number of reads and writes. If I really have to write simultaneously, I can of course use a second database with a second thread. For example, I write my addresses and invoices in two different tables of a database, but for the logging that should run 100% parallel, I just use a second database. So I associate one thread per database file and they all run fine. Let's take a look at how this works. In the last session we created a VCL demo, because that was just a little UI to show the demo. This time it's a real application. Of course, I use FireMonkey. We also save the project for now. New directory. Then we have to make the appropriate setup in the settings. Since there is still no way where there is no predefined symbol to query the framework. We set the framework, and just in case, all the links we need for the search path. Then we set the name reasonable and name the form main view. If we have a main view, we surely need a view model for it. And then we create an empty class. Then we set the right framework in the form. And of course, we do the same in the application. Then we generate our start unit and get a predefined empty version of it. Who has seen the first session knows that I work with a higher resolution so that I don't have to drag the window into the visible area all the time. I just do it like this for the demo. I hope I haven't forgotten anything. Let's see if it compiles. It is also in the right place. So we created our basic MVVM application. That was just under 4 minutes in real time. With a wizard it probably would have been just a click. So, what do we want to do today? My idea was that we go and do a temperature monitoring program. So first of all, a temperature sensor. Of course, we take the temperature in degrees Celsius because water freezes at 0 degrees. So, what do we need? Of course, we only want to simulate a temperature sensor here, which means we will probably need a base temperature, and the maximum value the temperature should change. We're going to need our current temperature. We're going to need the old base, the differential temperature, and a tendency. Then we can oscillate between these values. Yeah, I like that. Then maybe so that it's all independent of time. How about actually, you should not use now directly either. Oh, here we have something. So there we take the time service and put it in from the outside. Okay, let's take the date utils and check it out. Then a random value. So this should actually work already. Then we should create a database. First we need a main model. And some interfaces. Of course, we do some dependency injection with that. No data context. For this, we better take a look at it in my next MVVM video. This is the F database. Then we create a database. To make it easier, we do it like this. We simply take a database that can store both locally and on a server. This has the advantage that if we want to store the data not only locally, but also transfer it to a server, we can use this database directly. Okay, what do we need? eProx. We take an event that tells us at what time it was measured. And we need the temperature. And we need the sensor number. Format everything a little bit more as I like it. So, the methods we take and copy them into our database class. Of course, we have to use it with the interface. This interface wants to have a clear method. Then we still need the usual suspects. We want to use FireDuck. We want to use the ORM framework. We want the CRUD interface, because database create, read, update, delete should be enough here. Then we will probably need the FMX helpers. And this is similar to the sysutils, the utils unit. Then we can say, this is a CRUD database. The name is TemperatureDB. And the table is called Sensors. Then we need a database field and I want to be able to search for the date. So I say this is a date key field. Then I need a normal field. And other field for temperature. We don't store the temperature in a floating point value, but in an integer with centigrade. It's nicer for the database. That should be good enough for now. Then we'll implement it quickly. This JSON store REST library I use here is able to use a local SQLite database and remotely transfer the data to a server via REST. You can use the same definitions on the server and the source where the server is included. There are additional default fields. The ID field, we also use that. And if you don't want to physically delete records, but only mark them as deleted, for the uniqueness AGUID, if you change the record version. For the event, we immediately hand over our time service again. Locally, we still need our time service. So we have a database. Then we still need an initialization part, so that the database also works. We register the database with the ORM framework. Then we register the CRUD functionality, so that the CRUD framework knows where to find the data on disk. I could now give a direct path here, but I do it differently. It should also run on iOS and Android, so I use this FDK function, and there the subdirectory temp. This should work so far. Can the whole thing be compiled? Right, we wanted to save an integer. Let's go to the place where the whole thing is initialized. So when the main form is created, we can get the view model and then the model. So I pass the time service and the database. So then we can pass the instance from the time service to both classes. We don't want to do this asynchronously but synchronously. And then it should work. Let's take a look at the directory here. Okay. And there is our local database. Of course, it is still empty. But the errors are all generated correctly, including the fields that are necessary to make the whole thing remote ready. So, a quick little something else. This looks kind of stupid. Then we should breathe some more life into the whole thing. That means in our model, of course, we need the sensors. The threads for that. And of course the thread that can write the whole thing into the database. So we need first the simple thread. Oh yes. And of course the queue. The interface actually has more than we need, but that doesn't matter, because the database behind it has a lazy init and is only created when it is needed. So we can take our main model and say, we create a worker thread. So our worker thread is our simple thread. That means, we can take the queue worker. But this time we give him I can store temps. So then the call would be in the thread context. Now, of course, I want to assign all data fields individually for access each time. That means I want to be able to assign the data. And I can simply say fdatabase.db_create. I don't want to do that asynchronously either, but directly. What we still need now is the assign in our interface. And we still have to add it to our database. We don't want to take all the default values from create, but the values we have been given. This is the database field, so we can also set this directly. So we do not have to do the conversion twice. This is how our thread should run. Now we just have to feed it with data. I could make a list, but in this case I'll do it static. This is now a bit of shooting at sparrows with cannons, because this thread can do a bit too much. But that shouldn't bother us. We just use the same thread definition and say, we're using the heartbeat event as a timer. And we want to hand over the timeout as well. Then we create this. Sensor thread is the sender. And from that we take the sensor ID. Of course, we have to lead the timeout to the outside as well. And this should also work. What we need now are our timers. And our sensors are, of course, iTemp sensor. Then we create the sensory. This is the wrong help. The first sensor starts at 21 degrees, has a 2-degree spread, and of course gets our time service. The second sensor starts at 18 degrees and can differ by 3.5 degrees. The third sensor is in the basement and starts at 15 degrees and 3 degrees. And that is in the cold store and starts at minus 21 degrees. That means we can pick up our data from the sensors here. Our work data, we use the same object as we have already defined here. The whole thing is of course this interface. That means, we create a new data set. Delete the values. Oh no, I actually wanted to do that differently, so it doesn't work that way, or that's exactly the trick. Then add the procedure here. Then we move the whole thing. What I don't like is this one, when we pass an instance to the model, but then link it statically. That doesn't make a good impression. So we use the instance we have. We need a new instance of it. Then of course we have to extend the interface. Then of course the implementation of it. The work data we just created can now get the temperature from sensor. We have the temperature and the sensor ID. And now we can take our work thread and say, process the data. Run. So that should work. We created our sensors. We created our worker thread. All that's left is to create our timer so that our threads can run. Sensor ID is 1. We want the first one. Maybe better with a constant. Then after our callback routine, the second one we query every 500 milliseconds. The one every 3 seconds. And the last one maybe every 250 milliseconds. You may have asked yourselves why we use the time service. The time service has a decisive advantage. It is not queried now but uses the corresponding routine which implements the time service. And the trick is, the time service can offer several functionalities. Let's just take a look at the implementation. You could say I want to have now. You can set a fixed time, with which now continues to work, because the delta time is used internally. I can stop the time service, which is especially interesting when I do unit tests. Then I can set a time, stop the time service, do my unit test, and I am not dependent on having to change the system time every time. I can check if the time service runs in real-time mode. And this is the trick I want to use here. I can make the time run faster and test if our threads still work then. so I can set the timescale and let the time run 2 times, 3 times or 5 times as fast and test a routine over a longer period of time without having to wait for real time. Okay. And that's the trick. Because the timeout from the sensor thread knows nothing about the timeout service. The timeout from the thread is not related on the time service. That's why I have to adjust the sensor interval to match the scale of the time service. By dividing the interval by the timescale, I get the right value. By creating out 4 timers, we're nearly done. 2 little things are still missing. If you want to call them little things. Interface. Interface. No interface, and the sensors are not interfaces. Therefore, we should release these instances. First, the sensors, so that they don't produce any more values. Then our worker thread. That should do it. I just see, of course, I need to have the timeout for double speed if the timescale is 2, so I need to divide the value and not multiply it. I hope I haven't forgotten anything. Let's see if it works. Of course, the application is completely reactive all the time. Then let's take a look at our database. Nice. I would say that looks good, and there are many values in the database. So before we run out of time, maybe a little bit for the view, so we can see something on the screen. Where do we place our call for the UI? Best here where the sensors are called. I do this now completely independent of the D.MVVM framework, just in the conventional way. By saying, I have a procedure from the view model. I want to pass the sensor ID and the temperature. So 1 integer and 1 single. Next step is our view model. Here we create the same procedure. On creation, we could pass the procedure from the view model down to the model. Then in the view, how about a round rectangle? Background fill blue to red. Then another rectangle in silver, like mercury. A line client and a few margins. Certainly not the most beautiful temperature display, but that was not our goal for today. We have a total height of 230, so if we say line bottom with a height of 115, there we have 0 degrees. We will take 4 of them. To make it simple, we create also 4 t-edits to receive our temperatures. So if we get a change event on our t-edits, we could update the temperature display. So our scaling is 230 pixels divided by 30 degrees. Temperature multiplied by 100 times scale plus 115. Two, 3, 3, 3, 4, 4, 4. Then in the view model, take the properties. For temperatures. When the view model is passed to the view, let's set some more values. Okay. Now we can do the following and say timescale times 8. Yes, that looks good and seems to work. Of course, you could format the temperatures even better on 2 digits, but that's not what this demo was about. Now this was of course an absolutely simple example how to access the SQLite database with multiple threads, but my main goal was to demonstrate the technique. If you say, okay, I'll make it a bit more advanced. Then of course you can get the thread serializer from the FDK. This of course provides the corresponding status information of the thread. You can register actions. You can specify debugging. The whole thing then uses internal debug engine. And the threading command worker who can process the threading commands is a bit more advanced, too. But in the end this little demo showed how to tackle the problem. I hope you like the new style of this session, not only showing finished source code, but really developing the code line by line.
There's a fire burning out on the street. I can't bear this heat. You claim it was my fault, but I know it